we go. Let's take a look at 6.1, a new chapter. We're going to talk about similar figures here to get things going. So I got a little Halloween shout out. I know it's past Halloween unless you were crazy far ahead of pace or something. So I got these two pumpkins. I got a pumpkin and a pumpkin. Why do I got that going on? We're talking similar figures. What are similar figures? Well, here are some examples. I got like a mama giraffe and a baby giraffe. I got a big pumpkin with this little pumpkin and these two stars. Similar figures are what? They are the same shape, but if they were congruent means same shape, same size. Similar means same shape, different size. So we're going to take that shape, we're going to make it a different size, but we're going to keep the shape the same, and that's going to be similar. Fantastic. So here's a little star. It's the same exact star, I just made it bigger. So same thing with the giraffes. So you may see some similar figures out there, out and about. Let's get the formal definition of it. So that's really what we're talking about this entire chapter. It's a quick one, only 3 sections. Two polygons are similar polygons if corresponding angles are what? So let's take a look. If I draw like maybe a some kind of weird trapezoid, and if I try to draw that same exact trapezoid only bigger. Ooh, that's a little rough. Hope your picture turns out better than that. What has to be same about these angles? Well, if this is sima, S-I-M-A, this is the symbol for similar. So it's like the congruent. Remember, congruent was with the equal sign. It's exactly the same. We just take the top off and say, these are similar. So sima is similar to lur. I get it, Mr. Brust, similar. Very nice, very nice. So these two are similar, same shape, different size. What has to be true here about the angles then? Well, if I look at angle S, it's got to be what? It's congruent to angle L. I is congruent to U. M is congruent to R. And then 1, 2, 3, 4. 1, 2, 3, 4. Excellent. So the corresponding angles are congruent. Fantastic. So what does that mean? We still have corresponding parts just like we did. This is very similar. I hate to say that to chapter 4 on congruent, but it is. We still have congruent parts. So S is the same thing, and we just marked this to L. We said I is congruent to U. M is congruent to R. And what was the last one? A is congruent to E. So naming is very important again. So they have to match up when you name it. S is to L, I is to U. They have to match up when you're naming these. Also what happens is sometimes, you know, like if we give some dimension to this, if this is 2 inches long, maybe this is 4 inches. So what happens here? Well, we're going to say this one is twice as big. So we're actually going to look at ratios now. So if we match up the sides, SI, the distance of SI, is going to be proportional to, it's going to be the ratio to L to U. And that proportion's got to be the same as what? It's got to be the same as the distance from IM over UR, which has got to be the same as the distance from MA to RE. So let's say that was 3. If MA is 3, what does RE have to be? Boom, it has to be 6 because it's twice as big, or you can say the top one is half the size of the bottom one, which again has got to be same to what? AS has got to be the same as LE or EL. It doesn't really matter. Excellent. Very good. So going around, that is what the formal definition of similar is. So let's use it to solve some problems here. Let's get this rolling here. Let's only look at the left side here. So I'm gonna close off that right side just so it's not a distraction for us. Boop. And let's take a look. So what do we got going on here? Well, it looks like, whoa, let me change colors here. I've got these two triangles. I'm going to tell you they're similar, so I'm going to say triangle UTS, and there it is. That little wavy line is similar to what? So U to T to S. Remember, I flipped it just like I did before. It looks like U should match E, so triangle, put a little triangle there. U matches E. E to F, so E to T. So this side is this side. Fantastic, they match up. How about this? F to G matches what? It matches T to S. So when you're naming this, this has got to be UTS is congruent to EFG. UTS EFG. Let's go ahead and mark that last side with green. So this side matches this side. So again, we can flip it, spin it, all that fun stuff. And it should come up with that. So naming is very important. So what side matches what side? Well, let's check this out. If FE is to UT, so 14 over 9, or you could, or I'm sorry, over 49, or you could flip it, 49 over 14, doesn't matter. I'm just going to go from small to big, as long as you're consistent. So I'm going to go small to big. You could easily go big to small as long as you're consistent. That's got to be the same thing as what? Let's do green. 24 is to 84. And that's got to be the same thing as what? 28 is to 98. So for them to truly be similar, all that has to be true. Let me see if I can pull my calculator up real quick and to make sure. And then we're going to look at a scale factor here. We're going to want to say, okay, how much bigger? Is this twice as big, 3 times as big? It could be a decimal. It could be 9.7 times as big here. Oh, here comes my calculator. Boom, let's plug it in. So let's clear this out and clear all that stuff out. Let's try it. Is 14 divided by 49 equal to, there's my ratio, 0.2857. Crazy. Is that equal to 24 divided by 84? I hope so. Check that out. Pretty cool, huh? Same number. And how about 28 divided by 98? Yes, bring that in there. I like that. So that is the scale factor. So it's not friendly like last time I was doubling it. This triangle is 0.285 the size of this one. So you could say your scale factor is, you could do a couple things. You could use a fraction. You could say it's 14 to 49. Or you could say the scale factor is 0.2857. Is it okay to do it the other way? Sure. You could also do it the other way. You could easily clear that out and say big triangle to small triangle has got to be the same thing. And you can flip them all if you want. 84 divided by 24. 3.5. So again, it's the same thing. So if you'd rather do that, you're more than welcome to say, sure, I think the scale factor is 49 to 14. And then that was a scale factor of 3.5. And that one may be a little bit prettier to look at, this one here. So what is it from the small to big? This is 3.5 times bigger. So if I take all these sides times them by 3.5, I get the other side. But either way works. Fantastic. Let's move on to another example. So can we use this? If you're good at proportions, you're going to love this section. You just got to do corresponding parts. So this side is this side. So I'll say question mark, or x is to 24 as what? Well, the top is to the top. So 12 is to 18. And again, consistent from the small trapezoid to the big, not trapezoid, small parallelogram. Not parallelogram. What is this? The small quadrilateral to the big quadrilateral. Then can we solve this? Sure. Hopefully we can solve this. You just cross multiply. So we're going to say this times this times this. So we're really looking at 18x equals 24 times 12. So let's clear this out. Can we clear that out? Yeah. 24 times 12 is 288. And then what are we going to do? We're going to end up dividing that by 18. So we end up getting 16. But let's write all that out. This is 288. Then we're going to divide it by 18. And what do we end up with? We end up with 16. Does it seem reasonable? I always double check my work. 16 is 24, 12 is 18. Sure. Seems very reasonable. Good answer. Awesome. One more of these. Oh, be careful because I flipped it and spun it. So let's find 4. 4 is this nice side here. What matches 4? I think it's this one over here. So a little bit trickier to see because it's not congruent. This side touching 4 here is got to be this side. Now this is nice because I only gave you 2 over here and 2 over here, so it's got to match up for it to work out. But if all were labeled, that could be a little bit trickier. So let's line them up. So we've got green is to green, so 4 is to 8, and maybe you know it. What's going on here? 4 times 2 is 8, so what does this got to be? It's got to be 7, doesn't it? 7 times 2. But even if you didn't pick up on that, no worries. 4 is to 8 as x is to 14. Do your cross multiply. X is to 56, so x is 7. Fantastic. Moving on. I love it. Love it. Can we find x in this case? So I kind of upped the ante a little bit here. Now they're all filled in. I like it. So this side over here, 20, matches who? It matches 24. So the small side, I always go small side, then I look for the medium side, and then I look for the long side. There it is. Boom. Boom. Awesome. So now can we step an equation? Lots of options here, you know. As long as you're consistent, small to big or big to small. I'm going to go red. Let's do red. So we're going to go 30 is to 4x minus 4. And matches what? Let's do green. Let's say 30 is this side is to this side, so 40 is to 48. Awesome. Can we cross multiply and solve? Okay, so we got it set up. So we're going to do our cross multiply again. And so we've got 30 times 48. 30 times 48 is going to be 1, and don't forget the 0. So 1,440. And the reason I picked this side is so we can see this. Remember, you got to distribute. This is 40 times 4x minus 4. So some of you may be like, Mr. Brust, why'd you pick those? If you could have stuck with numbers, it would may have been better. But I really want to show you this. Don't freak out if you run into distribution. Just distribute to this to both of them. So 40 times 4x, 160x. 40 times 4 is 160. We're looking at 1440 on the other side. And just solve this. What do we got to do? Add 160 to both sides. Add 160. So we're looking at 160x equals, what is that? 1600? Oh, that's nice. 1600. So what do we got to do to both sides? Divide by 160. Divide by 160. X should equal 10. Does that make sense? Plug 10 back in here. What is 4 times 10 minus 4? Well, 4 times 10 is 40, minus 4 is 36. Does that seem reasonable? Sure, that seems like a pretty good. It was the medium side in both of them. That's how I check. Medium side in both of them. I'm good to go. Awesome. One more example of these, and we'll move on to some overlapping. That'll be exciting. So same thing. Blue is to blue, and we've got green is to green. So here I'm forcing you to do it maybe the tricky way. So blue is to blue. So 3 is to x as what? X is to x plus 6. A lot of x's going on in here, but match up your sides. Holy cow, don't freak out. Do your cross multiply. So let's do this way. You know, x times x is what? X squared. Then I'm going to do this way and say this is 3 times x plus 6. Wow, so there's my cross multiply. Let's distribute on this side. So we're looking at x squared equals 3x plus 18. Now I've got a quadratic, or I've got the square, so what do I have to do? I have to set it equal to 0. And again, I really like x squared positive, so I'm going to move this over. Okay, so what do? We want to get, we have x squared, so we want to get everything to keep this positive. We're going to move everything over to this side. So I know you moved either side, but to keep x squared positive, we're going to have to bring it over here and say x squared minus 3x equals 18, because they cancel. And then it's still not equal to 0, so I got to subtract 18. And you can do that all in one step if you like. So now I'm left with, okay, so subtract the 18 from both sides, and we're looking at x squared minus 3x minus 18 equals 0. And then now we're to factoring. So we're going to want to factor this bad boy. So off to the side here, we're going to say what multiplies the negative 18, adds or subtracts to negative 3. And let's fill in those factors. So it looks like it's going to be 3 and negative 6, because 3 times negative 6 is negative 18. 3 plus negative 6 is that. So this breaks down into x plus 3, x minus 6. That equals 0. So what makes those parentheses 0 if this is negative 3 or 6? So those are my two solutions. X could be negative 3. X could be 6. They both work. Plug them in. Excellent. Very good. Moving on. Overlapping triangle. So don't freak out here. Same thing, but let's check out who matches who. So here's my small triangle, the big triangle. So this side over here matches what? The whole big side down here. Sometimes it's hard for people to see. This side matches what? This side over here. And then we've got the blue side over here. Whoa, I missed. Matches what? It matches this whole side over here. So it's kind of tricky to see who matches who in there. But if you can, the small to the big, and you're good to go. So let's set this up. Just make sure we're okay. I'm going to go small triangle. So I'm going to say x is to 12, green is to green, 6 is to 9. I can't use 11 because I don't know what this is up here. And then we can cross multiply, solve for x. And how many times ago that? Looks like x is 8. And maybe you saw the proportion in there already. How about this? Another overlapping one. So again, RC in the small triangle matches what? RT in the big triangle. Let's do red. It looks like RB in this triangle matches the whole thing in this triangle. And then you've got your bottom down here matches the whole bottom down here. So again, if you can kind of think about that, or even color code them, however you want to do it, as long as you get the right answer. We're looking for x, so I got to use 4x is to 80 as what? 4x is to 80. Your choice. You can go red to red, green to green. I'm just going to go red to red. 39 is to 130. And then we've solved a couple of these. You can pause it, try it real quick if you like, and I'll put up the answer. All right, there's the answer to the last one there. X is 6, and you can plug it in. That makes 24, so that seems very reasonable as far as your small side. Excellent. So I'm going to end you with a little Halloween clip. Hope you do well in the mastery check. Peace out.
Daai lippies wat die van die radiator by cab of dan is hulle net 'n bietjie uitgewys.
Ja, ek moet dit rekord want ek moet dit vir die baie so van die volk te plekke sê.
O, sorry man.
Ja, so.
Sê gou gaan wys.
Dis
Okay.
wat